Okay, so lesson 11. You should have your quizzes back. Make sure if you have any questions, you make sure you ask. This is really crooked. Let's see if I can fix that a little bit. Okay, so it says, consider the equation x squared equals 3x plus 4, where x represents a real number. Are the expressions algebraically equivalent? So, does it tell us what x is? That's the key. If it does not tell us what x is, we cannot say that they are equivalent. Let me phrase that. They are not, that they, no, Mr. H, that they are algebraically. Algebraically, am I spelling it right? I don't really know. Equivalent. Okay, we cannot say that. But we can find out if they're algebraically equivalent once we give x a value. So we skipped a lesson. Lesson 10 says, is this equation true? When I substitute something in for a variable, does it make the equation true on both sides? So I don't feel like I needed to do that with algebra, that if we substitute something in, you should know, hey, it's true, it's not true. So here's what they're doing. They're sifting through answers. Well, wonderful. They're saying, here's the rejects. Only one thing can go through if it's true. So they substituted in 0. 0 squared, because the equation was x squared equals 3x plus 4. Okay? 0 squared, 0. 3 times 0 is 0, plus 4 is 4. So does 0 equal 4? No. Does 25 equal 15 plus 4 is 19? No. So you're just trying to see what numbers work, but then all of a sudden, 4 squared is 16, equals 12 plus 4, which is 16. So 16 equals 16. That's why this is true. So if I said, is x squared equal to 3x plus 4, is it algebraically equivalent when x equals 4? You'll say, yes, it's algebraically equivalent when x equals 4. But this is I don't want to do this. I don't want to have to check every single real number in the world to find out what's true, what's not true. Because first off, we don't have that kind of time. Ain't nobody got time for that. So what are we talking about today? Well, this one's nice and easy because it's an equation. You know how to solve equations. You already can look at 7 plus p equals 12 and say, yes, it's 5. But how are we going to write the number sentence? 7 plus 4 equals 12. Well, that's 11. That's not true, so it's false. If I put in 1 plus the square root of 2, that's not going to be true either. So it's 7 plus 1 plus the square root of 2 equals 12. Well, that's not true. And you're going to keep on going, and you're going to realize that p is the only one that works. That's fine. The solution set of an equation written with only one variable is the set of all values. It's the solution to an equation. But a solution set is written a little bit differently. Okay? A solution set, and this is the key word here, is a set is written a little bit differently than how we've been solving equations. So, what do you mean, Mr. H? Well, I mean, solve for a. A squared equals 25. Now, I personally know how to solve this. You might too, but let's think about some numbers. So squared means the number times itself. So a times a is really what this is saying, equals 25. What times what equals 25? Well, you should all be shouting behind your computer that 5 times 5 equals 25, and you can tell me a equals 5. And I'm going to say, yes. What else can a equal? Well, a times a equals 25. Oh, what about negative 5 times negative 5, Mr. H? Yeah, because a negative times a negative is positive, so a equals negative 5. So how would I say this? If I would write it out, I would say a equals 5 or a equals negative 5. The solution set, though, is written in these brackets. And we start with the smaller number and we put a comma. Notice they're brackets, they are not parentheses. Parentheses mean something different. This is the solution set for this equation. Now, if you're saying, Mr. H, how would I actually solve this equation? Well, a squared equals 25. To solve a square root, to solve a squared problem, you take the square root of both sides. The square root of a squared is a, but anytime that you take the square root of both sides, it immediately becomes a plus or a minus. Because there's two options when we have square roots, which we'll find out more. That's how I'm getting a equals positive or negative 5. Okay? Now I've already answered all of the stuff that the next thing says, because this is the solution set. Right here is the solution set. But it says, hey, in words, show it to me. In a graphical representation, show it to me. So let's see what happens. So they've written it much more eloquently than I have. In words, a squared equals 25 has solutions 5 and negative 5. When a equals 5 or a equals negative 5. Here's the solution set with the funny brackets. But you can also represent it graphically. So you put a number line, closed circle on negative 5, that's a solution. Closed circle on 5. Are we still going to shade? Yes, we will. Don't get worried about that. How set notation works, don't worry about that. As soon as you have an answer, you put it in set notation, and that's just fine. A squared equals negative 25. Can you think of any number, something times itself, where I'm going to get a negative? Well, the only way to get a negative is having a positive times the negative, which this isn't saying positive a times negative a. It has to be the same number. So there is no solution. So how do we show that in all of these different ways? Well, I thought I showed it again, but you're going to have a null set. Hold on, let me try this again. Pay no attention. You're going to have a null set. And you can put something like that has null, because that's no solution, on the graph. You just put nothing, because there's no solutions. And how would you say this? There is no solution for this problem. Okay? So, moving on. Yeah. So start exercise 2, pause me, do exercise 2. Okay, so subtract 7, p equals 5. So I would say in words, 7 plus p equals 12 has a solution of p equaling 5. 5. 0. 1, 2, 3, 4, 5. And I would put a closed circle on 5. Plain and simple. Plain and simple. So, what else can we do? Well, we're also going to have inequalities. Well, before we even get to inequalities, let's talk about this. X divided by x equals 1. Is that true? Well, it works for 2, 7, all of these positive numbers, it works. What about for all the non-zero? So all the non-zero numbers, -1 divided by -1 equals 1. That's true. -20.135 divided by -20 and 135 thousandths equals 1. That's all true. So how would I write this in words? Well, I could say the solution set is the set of all non-zero real numbers. Why does 0 not work? Well, if you put 0 divided by 0 in your calculator, you get a funny message. So how would I set this up in notation? Well, I would say, okay, here's this. And I would say something to the effect of, for all real numbers. Okay? So you would actually need to write, x has to be a real number. So I would say x is real, and then I'd put a line. And I'd say x cannot equal 0. That's the only thing that it's not able to be is 0. So how would I show that on this graph? Here's 0, there's -20, here's +20. What would I have to put at 0 to show that that's not a solution? To show that it's not a solution, we put an empty circle at 20. Well, how am I going to show everything else works? I shade this way, and I shade this way. All of those are solutions. The only thing that's not a solution for x divided by x is 0. That's it. Okay, so let's keep moving on. Let's go to some of these other inequalities. So if you look at exercise 4 before we get to an inequality, so I'm on exercise 4. It says, hey, solve for a plus a squared equals a times a plus 1. Describe carefully the reasoning that justifies your solution. Well, they're the same. How do I know they're the same? Because if I distribute, which is what we should do, we get a squared plus a. So I could say x real, and then I put all real numbers. Because no matter what, it's exactly the same. All real numbers will work. Whatever I put in for a, it will work, including 0. How would I graph this? Well, to graph everything, there's 0. I don't have any points. I just have shading everywhere. Okay? But shading is going to be important here in a second, especially when we start doing inequalities. Okay, so identify the properties of arithmetic. Well, this is distributive. This is commutative. This is distributive. I'm not worried about that. I'm worried about this. And we've got w plus 2 is greater than 4. Well, if I subtract 2 from both sides, we know w is greater than 2. So how would I write this as all of them? Well, right now we're in set notation. We know that w has to be a real number. So I would say w real. I draw the line, and then I would physically put w is greater than 2. To graph this, can an answer be 2? Well, no, 2 is not one of my solutions, because it's got to be greater than 2. So I put an open circle of 2, and I shade everything greater than it. Exercise 7 is tricky. I like this one, though. So, we're looking for something for b that is greater than or equal to 9. Well, let's just solve b squared is equal to 9, because that's the easiest place to start. B squared is equal to 9, which means b times b equals 9. Well, 3 times 3, or negative 3 times negative 3. Either of those will work. So when I make my set notation, I say b real, and then I've got w is greater than 3, or equal to 3. Why? Because 3 is greater than 9, so 3 squared is 9, which is equal to 9. What about 4? 4 squared is 16. Oh, that's greater. Well, what about for the negative 3? Do I put greater than? Well, no. And here's why. I need to put less than or equal to negative 3. Because negative 3 times negative 3 is 9. Less than that is negative 4. Oh, negative 4 times negative 4 is negative 16. Or is positive 16, which is bigger than that 9. So when I graph this, I've got two things. I've got 0, 1, 2, 3. 1, 2, 3. We're going to have a closed circle on 3. All of these numbers bigger than 3 work. And all of these numbers smaller than negative 3 works. Knowing how to read it and how to interpret it is going to be very, very important. And I think that's our last example. So the lesson summary, which is rather important today. Coming back to this might not be a bad idea to write down some things that you need to know. Okay, the solution set is for only one variable, so we're not dealing with x and y. We're not doing that. To solve an equation means to find the solution set. So in words, we know that it's here. Solution set's the funny brackets. It is awkward to express the set of infinitely many numbers in set notation. In these occasions, we can use the variable symbol number type and a description. So still set notation, but it's talking about more than one number. So here's how we're writing it on a number line. And in this graphical representation, a solid dot is used to indicate a point to be included. If it's not included, It should be a open circle. Questions, concerns, problems, make sure you make the circles big enough that we can see them. Lesson 11, done.